AT&T Fiber 300 Internet. Moving there from Cox, just got it installed. And here's a video on it because the installation was quite different than anything I saw on YouTube. I expected one thing and got another, but the service itself is everything I expected. So we'll get right to the speed test since that's what everyone wants to see. But I think the more interesting thing is the installation. Then we'll talk about that and also some information on the Wi-Fi router. There's some interesting stuff going on there too. It will be of interest to those of you looking forward to possibly getting this service. All right, we are looking at the 5 gigahertz speed test now on my phone, right in the same room as the router. As you can see, the download speed is over the advertised speed. The upload speed is a little less. However, I can tell you when I had a laptop plugged directly into the router with Ethernet, the upload speed and the download speed were both well above advertised speed. So the 2.4 gigahertz is a little bit of a different animal. My phone says that the link speed is 144 megabits, and I'm only getting about 60 megabit download, and this is in the same room with the router. Now I know that the link speed can be a little optimistic, but even if we assume a link speed of 72 megabits, which is a single 20 megahertz channel on N, we're still down significantly. Another interesting thing about every 2.4 gigahertz bandwidth test I've run is that the upload is usually faster than the download. So that's some very interesting results from the router using the 2.4 gigahertz band. The band does have some pretty good reach though. I'm getting a really good signal way back in the back bedroom, so that's nice to have, although I don't feel like the performance is quite what it should be. It does hold its own, so we will get into how to distinguish the 5 gigahertz and 2.4 gigahertz later. So when I went online to try and find out what my install would be like, I saw some encouraging things. I saw fiber loop box on the outside of the house. I saw cables fish through walls. I saw ONTs, or the optical network terminals, mounted on the wall with a nice little cover that covered all your wires. And my experience was a bit different. I didn't get any of these things, not in the way that they showed on these videos. As a matter of fact, I don't think I ever ran across one video or one explanation online that described anything like what I got. The service works, so I guess that's all they care about. As you can see here, the fiber loop is hanging up on the roof, hole through the wall, big black obvious wire right down the wall with staples. How do you staple a fiber optic wire? Very carefully. And an ONT, or an optical network terminal box with no cover. He said that AT&T doesn't do those anymore. So this is just very interesting to me. Given that the installation was free, I would have been more than willing to pay an extra $100 for them to fish it through the wall and do a little bit nicer of a job, but it wasn't even offered to me. This is the way they do it. And here's the tool. Big drill, big bit, bing, bang, boom, done. So it's not like he didn't have the time to do it right. If I'd have paid him the money, he sat out in his truck for several hours after we were done. Well, anyway. So, but at least he stapled it to the wall, right? So interesting there. So once you get into the house, the little hole that the fiber goes through, he did not caulk that hole. I'm going to have to caulk that hole because to prevent water intrusion. I've had too much problem with other holes around the house letting this stuff in, so I'll have to take care of that. One of the things I'm a little concerned about is if you shove something over here in the corner, breaking that little fiber optic cable, that little bit that goes from the hole to where it's first stapled in the wall. Now if you see the baseboard stuff, I shoved a box over there just to measure it, and it doesn't quite touch the cable, but if you put a filing cabinet over there and it tips over and it pushes the cable and cracks the fiber, and then AT&T's got to come fix it, and I'm sure I'd have to pay for it. So I mean, other than the obvious black cable along the wall, which is sort of unsightly, which really makes me want to run out and get a can of paint. Uh, that's the other thing that irks me about this installation. So there you have it. So the router, as it comes initially configured, has the same network name for both 2.4 and 5 gigahertz bands, which is fine for the person who doesn't know a lot about the technical details of setting up Wi-Fi. It allows the router and the device to choose which band is appropriate given the conditions. In my case, I like to decide what goes on 2.4 and what goes on 5. So I went into the router, I changed the configuration, set up different network names and passwords for both the 2.4 and 5 gigahertz radio. And it allowed me to do this, and it works quite well. But it gives me some notifications in the Smart Manager app and elsewhere that you really should have these together. So I don't care, but that's the way that is. And especially I have an issue with one computer that when the 2.4 and 5 were the same, it connected to 2.4, although it was 5 gigahertz capable. I'll tell you about the issue with that in a moment. But by separating out the networks, I was able to go ahead and troubleshoot that, and also tell, okay, this device works great on 5 in this part of the house and 2.4 in that part of the house, and so on and so forth. Another interesting thing I noticed is out of the box, the router has IPv6 turned off. That is very interesting. I've seen this before with, for example, Netgear routers that to this day don't handle IPv6 properly. So no wonder they have it turned off, because if you turn it on, at least the last Netgear router I had about a year ago, your whole network would come down within 3 days because your computers would expect to traverse IPv6. It would stop working, it wouldn't fall back to IPv4 correctly, yada yada. But I'm pretty confident that this is going to work because the IPv6 implementation on this modem is from AT&T, designed to work on their network. And the only independent router manufacturer I've seen that's had a thoroughly, consistently working IPv6 implementation, at least on the consumer segment, has been ASUS. So there you have it. Turn IPv6 on, you should be good to go. The IPv6 test worked great. Once I went ahead and did that, I didn't need to change any other settings for IPv6 except to turn it on, both on Windows and on my phones. IPv6 did just fine after that. Okay, and I wanted to cover the 5 gigahertz bands because this actually had an issue with this. Connecting my kid's desktop computer to the Wi-Fi when it was initially the same network name for both bands refused to connect to the 5 gigahertz band. And as you will see on this 5 gigahertz channel allocations table, you have DFS channels in the middle and non-DFS channels on either side. So the router was selecting one of the DFS channels for the 5 gigahertz band, and the 5 gigahertz adapter I have in my kid's computer does not like to connect on DFS channels for whatever reason. So by going in and changing the channel setting, I was able to establish that 5 gigahertz connection from my kid's computers. My kid's computer. What's interesting here is when you choose the band or choose the frequency for the 5 gigahertz channel, you only get 36, 40, 44, 48, 52, and so on and so forth. And these are the 20 megahertz bands. But you see that the default channel width is 80. And if the default channel width is 80, you would be specifying the channels as 42, 58, and so on. So that's interesting that they list it all the way down to 20, which is probably fine. As you see, I have it set at 36. That puts me within the 42, 80 megahertz band, and that's exactly if I do a wireless test from my phone and see what channel that my router is on. It covers that 80 megahertz band at 42. Again, the router does do some of the DFS channels. It doesn't do all of the DFS channels. It skips over some of them, which is interesting, and that just may have been because some of those have opened up recently and didn't before. I'd have to research that and see. But yeah, so that's one reason why it was good for me to get in the router settings and configure that specifically, because otherwise that one computer wouldn't have been able to work on 5 gigahertz. So there you go. That is the speed, install, and modem specifics of my AT&T Internet 300 Fiber. I'm pretty happy with the service, and not so much with the install, but there it is. It's in there. The gateway itself is wireless performance is on par with what I had with the Cox gateway, so nothing special. I may add my own mesh system behind this, Orbi or Eero or something of that nature. Some of you may want to put your own router behind this. Most people, when they put their own router behind this, they want their router to handle everything. You may want to rethink that. Everything I'm seeing is saying that this can cause, even when you put the AT&T modem into AP mode or pass-through or bridge or DMZ, whatever you want to call it, whichever way you want to do it. People are having service issues with speed and streaming and other things. So you may want to just continue to let the modem handle everything, and if you buy Orbi or Eero or whatever, just set it to wireless AP mode. But so your mileage will vary there. I can't tell you how that's going to work because all I have is the modem at this point, but I thought I'd bring it up. All right, well, thanks for watching. Hope you learned something and were greatly informed.